Welcome to our video on inventory management. Today, we learn more about the economic order and production quantities with the example of a pharmacist ordering vaccines.
Hi, my name is Laura and I'm a pharmacist in St. Gallen. I just got some exciting news. They have finally come out with vaccines for COVID-19. I'm wondering how much should I order?
Hello, Mother. I just got back from my day at the University of St. Gallen. Can I help you with anything?
The vaccine for coronavirus are finally available. I will place an order for the pharmacy. Do you have any idea on how to proceed? Otherwise, I will just place a random order.
What a coincidence! I just had a class on inventory management. I'll explain you how to optimize your order quantity.
When minimizing costs and deciding how many units of inventory to order and how often, inventory managers take many variables into consideration. Right off the bat, we need to know the annual demand, the price per unit, costs per order, and holding costs. Here are our fictitious values. Let's now take a look at the formula for the economic order quantity, EOQ, and then see how we can input our values. The optimal order quantity is the square root of 2 times the demand times the cost per order divided by holding costs. By using our values above, we get the square root of 2 times 44,000 times 800 divided by 3, resulting in an EOQ of 4,844 for an average stock of around 2,400 units. So ideally, the pharmacy should order in batches of 4,844 units. But before we relay the info to Laura, there is a last concept that management must consider in order to avoid a stockout: lead time. However, this has no impact on our formulas. It's simply something to take into account. We have our EOQ, but what if we make a mistake? Let's look at different scenarios and put Excel to work. Here we have many possible order quantities. We can compute the number of orders per year associated to the order quantities. Then we can calculate the total order costs. Then, using the average order quantity, so average inventory, we can calculate the holding costs. Finally, we can calculate the total costs, which we want to minimize by adding both. Here, we also have a column showing the total yearly costs, including the price per unit of 15. We can now drag down the formulas. We see our optimum requires 9.1 orders per year, and we can see that it is in fact the lowest cost. This is all a bit convoluted, so let's try to illustrate with a graph. We can begin by defining the relevant values, and then continue by plotting the graph. It shows that the cost in function of the number of orders. Most important is the gray line, showing the evolution of total costs. And we can see a minimum at 9.1, corresponding to our EOQ.
Novartis are very happy and wants to offer us discounts if we place larger orders.
Exciting news! I will need to run new calculations taking into account the offer discounts.
So, the more we order at once, the cheaper the unit. Sounds like a good deal, but is it enough to offset the higher holding costs we would get? Let's find out. Here is our discount table. Each 5,000 units we get 1% extra off. Let's analyze each discount bracket to see which one is optimal. First, we need the EOQ of each bundle. Well, to no surprise, it's still 4,844 because price plays no role. But in bracket 2, from 5 to 10,000, this is not an option. So we simply settle for the nearest value, which is 5,000. Same goes for all other brackets. We now have optimal order quantities for each bundle and can directly compute total cost, putting it all together. We see here we get the same value for the old EOQ because there is no discount benefit. And actually, there is a new optimum at 15,000, costing us 10,000 francs less. Now let's only hope Novartis are optimizing their production process.
Hi, my name is John and I'm the CEO of Novartis. We are so happy to announce that the COVID-19 vaccine has finally been developed. It's time to produce as many doses as possible. We'll be the richest pharmaceutical industry in the world.
Excuse me, may I interrupt you? Hi, my name is Sarah and I'm the Chief Operating Officer at Novartis. I'm so sorry to interrupt you, Euphoria, but I don't think that producing all the vaccine as soon as possible is the best idea.
Why not? Could you explain it to me?
Let me explain. Obviously, having all the doses ready in a few days and delivering all of them at once would speed up the process. However, there are some additional costs to take into consideration. I'll show you what I'm talking about by introducing to you the economic production quantity in Excel.
Left of the spreadsheet, there are all the relevant data that we have to deal with. And after choosing some arbitrary production quantities, we calculate the production batches needed for each alternative by dividing the total demand for vaccines by the alternative production quantities. The third column shows the total setup costs, which are equal to the number of production batches multiplied by the setup costs for each production. While the fourth column represents the total holding costs. These are calculated by multiplying the average production quantities times the holding costs per unit and per year, and when dealing with economic production quantities, we have to multiply the result by 1 minus the daily demand over the production rate. Afterwards, we copy the formulas to all rows. And we can see that if we produce all the doses as soon as possible, we'll have the lowest amount of setup costs, but at the same time the holding costs will be extremely high. So we just need to add the total setup costs with the total holding costs and find out what is the production quantity with the lowest value for total costs. In this case, it would be around 2 million doses, achieved with approximately 2 production orders. Alternatively, by plotting the costs in a graph, we look for the intersection between total setup costs and holding costs, orange and blue lines respectively, and that's the optimal production quantities. To make things faster, we could also apply a formula to find the optimal production quantity. The latter is the squared root of 2 times the total demand times the setup costs, all divided by the holding costs, times 1 minus the daily demand over the production rate. And as we can see, the result is the same as before.
Now you have learned the basics of inventory management with the economic order quantity and the economic production quantity. Thanks for watching, Team 8.